Now let's get started. So before I hand it over to our sponsor speaker, Mathieu Binet from Greatech, I'd like to say a few words about Greatech. Greatech has been helping customers for over 30 years now. Headquartered in France with a local presence in Montreal, Greatech is mostly known for being the third biggest Autodesk software reseller in the world, with over 500 employees operating in 15 countries and a research and development center in Romania. Greatech is much more than that, actually. So Greatech delivers an increasing number of 3,000 trainings every year, with our latest acquisitions, Civil Design in 2007, ProCAD and Zenit Consultants in 2018, and Geomap in 2019. Combined with our well-known BIM Up initiative, Greatech aims to be your partner of excellence and can help bring you to new stages of maturity around collaborative BIM and deploy your digital approach to better design, construct, and operate buildings. So actually, Greatech's products and services are sold around 4 main business pillars. You can see them on the screen. We want to help you create, simulate, and fabricate, as well as help you manage data. So create data-rich models enabling the best possible design decisions to be made with mainly the Autodesk products. Simulate the model's behavior to make them perform better with our product Advanced Design, which is a structural analysis software, and our Revit plugin called the PowerPack for Revit, as well as fabricate or construct as automatically as possible, driving down the costs of time and resources. And finally, we can help you manage data and want to help you manage data all throughout the process with mainly Opentree and Autodesk BIM 360, which is going to be the focus of today's presentation by Mathieu Binet. So I'll hand it over to you, Mathieu.
Okay, thank you, Sarah. So let me open my screen. Hello, can you see me?
Yep, we can hear you well.
See me now. Awesome. So thanks a lot, everyone, to be online today with us. So my name is Mathieu Binet. I'm the sales manager for North America at Greatech for 2 of our, let's say, line of products. First one will be Fabricate, that you saw earlier with Sarah. Second one will be Manage. So today we'll talk about a Greatech software. So Greatech has 2 different, let's say, hats. We are an Autodesk reseller, of course, but we are also a software editor that creates a software all linked to the Autodesk ecosystem. So today we're going to talk about Opentree, a quick 5 minutes. You can add me on LinkedIn here. You have the line, the link, Mathieu Binet. So just to come back to what we saw earlier, the 4 pillars. So we're going to talk about, like I said, Opentree in the Manage product line. So here you go. So what is Opentree? Opentree is a BIM compliant drawing and document management solution for architects and engineers, helping you to adopt a consistent approach and automate the non-billable activities. So Opentree, it's basically a document management software, but we created links directly with Revit, with AutoCAD, of course, everything Office 365, SharePoint, Autodesk BIM 360, and even MicroStation. So I know a lot of folks there are using MicroStation for civil purposes. So we have a link with MicroStation as well. So many small and big customers all around the world are already using the solution. It's around since, I will say, 20, 25 years. So big names that you know, Siemens, Alstom, Atkins, Tata Steel, they're all customer using Opentree right now. So managing document in an architectural firm or engineering firm, normally, if you don't have anything like Opentree, it's very hard to follow any kind of standard. So user, they do basically whatever they want. The traditional process work, but are like really manual and they're not scalable. You have a massive increase in non-billable activities, like, you know, looking for the most recent file on your network, it's not a billable activity. So we're trying to automate those kind of tasks. The project getting more and more complex, many offices, can be many countries. So having the right file with the right name at the right place from all the users is really, really important for a good organization. All the manual processes that people do, of course, are subject to, you know, costly errors, like Many times people are telling me, yeah, we worked on the wrong templates for a day or two. It was not the most recent one. We need to, do it again. And finally, when you have a audit, it's really hard to track back the information. So we'll try to help you facilitate that task as well. So Opentree, what is Opentree? Like I said, it's a document management software. What is really nice, we are kind of working in Windows Explorer. So the skin of the software is a replication of Windows Explorer. So that means training is fairly minimum when the software is set up. So Opentree will guide the user to create a new project, new files on the latest templates. We'll guide the user as well, naming the file correctly based on the company standard, the project standard, or the customer standard. Put the document into the correct folder, so it can be in SharePoint, can be in BIM 360. So we're trying to automate that task as well. Of course, working with Revit and AutoCAD drawings, sending them to the next life cycle stage, so it can be a CDE, common data environment, or you can send it by email, you can send it for checking, you can send it for approval. So this is all tasks that can be, again, automated with Opentree. Searching for drawings or documents. So we have an automatic indexation for all your file. So searching a document, getting a lot more easier. And also looking at history of events. So we were talking about audit a little bit earlier. So all the traceability of the file, who did what, when, on which computer. So you're keeping track on every single file in your office. That can be really, really important, especially if you have, sensible project. I'm thinking about, I don't know, infrastructure, things like that. Getting a good traceability of everything that is happening in every step is really, really important. And the system is really secure because it's an on-premise solution, so it's going to be on your own network. So finally, with Opentree, you get your secure structured data environment. We are compliant to ISO 19650. So the international standard for document management in the BIM industry. We're automating a lot of manual processes, reduction of manual errors, tight auditing control, reduction of the time spent generating transmittal and send it to, again, SharePoint and BIM 360, and a huge reduction of data management time and cost. So if you want to learn more, that's a 5 minutes really quick to explain what it is. So we have a webinar next week, Opentree for Revit, redefining drawing and document control in your Revit environment. So on September 9 at 12 p.m. EST, so Eastern Time. You have the link to register here. I posted the link in the chat box. You can click on it and just register there. You can also send me an email, matthew.bennett@greatech.com, and I'll send you the link. So yeah, that's it for me. Thank you very much, all. And Sarah, I'll let you.
Thank you, Mathieu. I don't know if we had questions. I can't see any questions in the polls or the chat area. Feel free to ask questions at everyone. I was wondering, Mathieu, you were saying that you follow the norm ISO 19650. Can we set up our own standards and adapt for different projects for different customers, or that's the only the norm we can follow?
Yes, you can create a template for every single project, different customer, different phase, especially for the file naming automation, where you automatically name the file. This is something you can adapt to everyone, or every different standard. It's just that the ISO, it's kind of the general BIM standard worldwide, but you can do whatever you want.
Okay, well, thank you for that. Thank you for your time, Mathieu. Now I'd like to introduce today's technical session, Implementation of Contemporary Energy Standards in Canada. So maybe we can switch presentations. So I'd like to introduce the first speaker, Mohammad Fakoor. Dr. Mohammad Fakoor is a senior building performance engineer at RJC Engineers. He is the technical lead for the building performance team at RJC, and his work involves project work, technical review, education, and energy modeling, archetypes testing, research, and carbon life cycle analysis. And our second speaker that will be joining us today, Maddie Reid, is a design engineer in the building science group of RJC's Vancouver office with experience in the design, review, and contract administration of new and restoration projects. So I'll hand it over to you, Mohammad and Maddie.
Thanks, Sarah. Can you hear me?
Yep, we can hear you well.
Good morning, everyone. I would like first to thank Cambeam for organizing this great event. And I would like to thank anyone who is attending this session. The title of this presentation is Implementation of Contemporary Energy Standards in Canada, Compliance with the NECB 2017 in Saskatchewan. So here is the outline of the presentation. I will first talk about climate change and energy standards. Then I will talk about NECB 2017 as an envelope first approach. Then I will discuss energy compliance pathways. Then my colleague Maddie will talk about prescriptive path, and she will focus on building enclosure. Then I will discuss prescriptive path, and I will focus on mechanical systems. And finally, I will talk about performance path. So climate change and energy standards. So one of the most important aspects of energy standards and energy modeling in general is the fact that they can mitigate the impacts of climate change. We are living with a changing climate. We are experiencing wetter winters, drier summers, and as you can see in the graph at the bottom right corner, the extent of ice has dropped significantly over the last century, and this will cause climate change and increase in global temperature. Moving to the next slide, and speaking of extent of ice, here what I'm showing is the increase in global temperature over the last century and compared to pre-industrial level. And as you can see, the Arctic is warming at a rate twice as much as the rest of the globe. So this means climate change is having the most dire consequences on the Arctic region. Now here, let's focus on Saskatoon. So here, what I'm showing in the graph at the left-hand side, the blue line is historical temperature, historical average annual temperature. And as you can see, as of right now, we are experiencing around 1.8 degrees C of temperature increase compared to the baseline or pre-industrial level. Now you can see the projection of temperature for different scenarios. Now, if you look at the status quo emission scenario, meaning business as usual case, if we don't take any action, if we don't reduce our GHG emissions, then by the end of this century, we're going to have over 8.5 degrees C of temperature increase for average annual temperature of Saskatoon. If, however, we reduce GHG emissions under major emission reduction scenario, we can limit that temperature increase to 3.6. So around 5 degrees C is really the value of action, and the effect of that, limiting that temperature increase would be significant for the ecosystem of Saskatoon. So based on the business as usual case or status quo emission scenario, the number of days with more than 25 degrees C will be doubled. And also we're going to see around 6-fold increase in the number of days with 30 degrees C temperature annually. So as a result of this, due to the importance of climate change, around 200 countries got together in 1995, and they signed the very first climate action plan called Paris Agreement. Canada is part of Paris Agreement, and Canada's goal is to reduce GHG emission by 30% compared to 2005 levels, to have 30% increase in renewable energy system share, and to reduce energy consumption by 30%. So these goals, we need to achieve these goals by 2030. So I follow Bill Gates on social media, and I recently so he recently posted a very good read on climate change, and he's pointing out that to understand the kind of damage that climate change will inflict, look at COVID-19 and spread the pain out over a much longer period. So if we don't take any action, if we don't reduce GHG emissions, the effect of climate change would be much worse than COVID-19. And I think this is very scary and sad for the next generation. All right, now let's focus on NECB 2017. So what is happening across Canada is the current code, or now we can say old code, is going towards passive house via contemporary energy standards. And one of those energy standards is the NECB 2017. Other energy standards that we see across Canada are BC Energy Step Code or Toronto Green Building Standard. So the common aspect of all these contemporary energy standards is the fact that they are very building enclosure or very envelope oriented or envelope driven. So they all have envelope first philosophy in them. Now, what do I mean by envelope first philosophy? What is the philosophy of passive house? I like this this illustration because I think it demonstrates the philosophy of passive house pretty well. So what essentially this slide says is in 19th century, we used to live in very inefficient building with poor building enclosure. And we use very simple, let's say, mechanical system like, wood fireplace for heating our buildings. In 20th century, we still had poor building enclosure, but we started to utilize complicated mechanical systems. But at some point, we realized that this approach simply doesn't work because we still had high GHG emissions. We still had high energy consumptions. So now passive house philosophy is to improve the building enclosure as much as possible. So now when you live in a passive house, you live in a very high performance building enclosure, and now you don't need complicated mechanical systems anymore because the heating demand is so low that you can simplify the mechanical system and you can rely on the thermal comfort that you gain from your enclosure. So here is an overview of energy standards in Canada. So on the left-hand side, you can see the energy standards that we used to comply with, like ASHRAE 91 2010, like NECB 2011 or LEED. But now we are going towards more building enclosure-driven standards such as BC Energy Step Code, NECB 2017, Toronto Green Standard, or City of Vancouver Zero Emission Building Plan. So essentially what's happening across our country is we are moving away from mechanical solutions and we are going towards geometric and envelope solutions. So again, this is the philosophy in passive house. Another strategy that we see is happening across Canada is electrification. But is electrification the right solution for every province? Let's take a look at this graph. So to answer this question, we need to understand what kind of sources we are using to generate electricity in our country. Now, if you focus on BC or Quebec or Manitoba, for example, you can see that the major portion of electricity is generated by hydro. Or even in Ontario, we are using nuclear power. So these are very clean sources of energy. So the grid emission for these provinces is pretty low. However, now if you focus on Alberta or Saskatchewan, for example, you can see the majority of electricity is generated by coal or natural gas. So here, I'm trying to quantify the grid emission, the emission factor for grid electricity for different provinces. And as I mentioned, and as you can see, the emission factor for Alberta, Saskatchewan, or Nova Scotia is significantly higher than provinces like BC, like Manitoba, like Quebec. So is electrification the right solution? Probably not at the moment. So what we can do at the moment is to focus on building enclosure for the built environment to reduce GHG and energy consumption as much as possible. But at the same time, we need to focus on using renewable energy sources to generate electricity in these specific provinces. Energy compliance pathways. So in NECB 2017, just like previous versions of the standard, there are three main compliance pathways. The very first one is prescriptive. So prescriptive is very straightforward. There are some clauses in the standard, and all disciplines, mechanical, electrical, building enclosure, they need to meet the code. They need to follow those clauses. However, it's not flexible, so it's very rigid, and then you cannot trade off between mechanical and building enclosure system under prescriptive. Trade-off is another approach which has a very limited scope, so I'm not going to touch base on trade-off in this presentation. And in trade-off, again, you cannot trade off between mechanical and building enclosure. So the most preferred approach is performance, which is done via energy modeling. And it's pretty flexible. You can trade off between electrical, mechanical, and building enclosure systems. Now, regardless of the compliance pathway, you need to know what is the climate zone for the region that you are doing the NECB compliance for. So, for example, here you can see a map of Canada, and in Canada, you can see we have different climate zones, and definition of climate zone is based on the number of heating degree days. So there are certain parts in BC with mild climate. They are like Vancouver, like Victoria, which are zone 4. And then as you go up north, you're dealing with a colder climate. So those regions will be climate zone 8. Now, if we focus on Saskatchewan, this is a map of the province, and you can see the major part of the province is at climate zone 7, A, 7B, and 8, meaning they have high number of heating degree days. Maddie, all yours.
Thank you very much, Mohammad. So I'm going to walk you through the prescriptive path in terms of how to achieve that, how to comply with that for the building enclosure. So first off, how do you know if you can actually comply with the prescriptive path? How do you know if you can choose that for your building? So you need to take a look at your fenestration and door to wall ratio. So what is the percentage of area on the walls that your windows take up? So let's say you're in Saskatoon, it has to be under 28.7% of your wall. And that's how you know you can go down this path. So let's take a look at what the NECB 2017 says in terms of fenestrations. And the prescriptive path is exactly what it sounds like. It defines the R values and U values for all of the building components, and it's up to the designers and the architects to ensure that they design their assemblies and choose the right products to meet these defined U values that are in the code. So as we can see here, if you're in zone 7A, 7B, zone 8, I'm going to speak in imperial units because that's how I think. You need to meet at least U at the maximum, U 0.33 or U 0.25. So for fenestrations, how difficult is that? You can see here we've given you the U values of aluminum window wall and vinyl and fiberglass windows. It's not that difficult. If you are in zone 8, you're likely going to have to go with triple glaze. Sometimes you can get away with, if you're in zone 7A, 7B, you can probably get away with a double glazed window, but it's not an issue. These products are readily available, and you can comply in terms of the fenestration requirements. So let's move along to see what the NECB describes for opaque assemblies. So you can see here they've described the walls, the roofs, the floors for both above grade and below grade. So here you can see, let's start with the roofs and floors. It's quite simple. The way to comply is to design and install the amount of insulation that kind of translates to these R values. So if you're doing roofs, it has to be at least R41 and it goes up from there. If you're doing floors, it's R35 and it goes up from there. This is all above grade, by the way. And so for the walls, it's not quite as straightforward as just installing R27 or R31 walls. You have to realize this in this new NECB 2017, they require you to take into account the effects of thermal bridging. So what does the NECB actually dictate around thermal bridges and what to consider when you're trying to find the effective R value of your walls. So you must take into account the effects of the structural members. So what does that mean? It means pretty much everything that intersects with your insulation. So structural members, both kind of major and minor. So cladding girts, studs, lintels, sills, and then as well major components such as slabs, even minor ones such as conduits. And then you have to take a look at sort of interesting geometry around your building. So you have to take a look at corners, parapets, roof-to-wall junctions, as well as where your fenestrations meet your walls. Everything must be taken into consideration. So this is a great visual that just allows us to take a look at the thermal bridges. You can see outlined on the left. The parapet is in yellow, the corner is in green, the perimeter of the windows is in blue, and the slab edges are in red. So all of these need to be taken into consideration. And you can use the equation, that's the general equation to use right there on the bottom. And so each one of these details, these thermal bridges, has its own psi value associated with it. And so you need to define the details and then define the psi value that goes with it, and then use the equation to spit out one overall effective R value that takes into account these thermal bridges. So how do you actually calculate it? Are you going to use your hand, your pencil and paper? You could in theory, but this is a really excellent spreadsheet created by BC Hydro, and it allows you to input all of your data, all of your psi values, as well as your clear field values of your walls, your wall assemblies, and it will spit out one effective R value for you to use as you go forward with your design. So let's take a look at how to meet the requirements in Saskatchewan for wall assemblies. So keep in mind, because thermal bridges can really reduce the overall effectiveness of your insulation, you need to go above and beyond your R27 and your R31. So you can't just stuff a bunch of insulation in the wall and assume that you're good to go. This is a totally different approach now. So you can do it in many different ways. If you look on the left here, we have a wall that has steel stud cavities. It's a much more traditional approach. It has exterior insulation. You're going to need quite a bit of insulation because you're probably going to need R40 and above in these walls to counteract the effects of thermal bridging. If you look at the graphic in the middle, you can start to get a little more efficiency out of certain kind of cladding attachments. You're looking for more thermally broken cladding attachments, and maybe some more high performance insulation such as mineral wool. As you get to the graphic on the right, it is a bit more rare in these climate zones, but this is just an example of how to achieve a high performance wall. There's not even insulation in the stud cavity here, and then you have entirely exterior insulation, but the key here is it's a very high efficiency cladding attachment clip. So this one is likely made of fiberglass or something like that. You're going to need quite a bit of exterior insulation if you're going with this approach. Likely in your climate zones, it's going to be a high performance clip, but it's going to look like the wall assembly that's shown there in the middle. And so these are a bunch of graphics. These are a bunch of walls you can build. You can see you're not really restricted in terms of exterior cladding. The key is no matter what wall assembly that you're designing, you need to take into account the interface of the thermal bridges. So a great resource is the thermal bridging guide, and it has all of the psi values, well, quite a few psi values for different thermal bridges that you need to consider when you're calculating the overall effective R value. So you can see here, it gets quite detailed. The guide has done the thermal modeling for many different architectural details. They take into account different structure types, so concrete, steel, wood frame buildings, and then many different kind of quirky and fine-tuned details around how is the insulation installed, how does a spandrel panel attach? Is the metal flashing attached to your walls, or is it kind of offset? So it gets quite detailed, and so you can comb through that guide and find the psi value that you need for your details, and then input it into your spreadsheet that I showed you before and get that overall effective R value. So let's take a look at the effects of thermal bridging. So in the image on the left there, you can see it's just a regular wall assembly. And so that insulation let's just say the nominal value of that insulation, it does add up to around R34. As soon as you take into account the effects of the studs and the girts and all that, you actually end up with only R10 effective. So you can see, heat loves to move through metal. It's highly conductive. It's not great, but it actually gets worse. So as you start adding thermal bridges, the image on the right, you can see you actually get down to an R8 effective as soon as you have that slab cutting through that insulation in your steel stud cavity. So as you can imagine, the effects of thermal bridging, they're really amplified across your building envelope as you have many, many different complicated details. Thermal bridging can decrease your nominal R value in your walls by around 30 to 60%. So how do you kind of stay on that low end of the decrease, right? So, decreasing your insulation in your walls by 60% is really costly. So here's a building in the image on the right. And if you just used regular kind of typical architectural details, a very typical approach to thermal bridging, so maybe some insulation on slab edges and maybe your average windows, that type of thing, you can achieve an effective R value of around 12.9 without really adding any insulation to the walls, but just by changing the details. So moving towards high efficiency details, very thoughtful, very creative detailing, you can actually achieve R15.6. So the details have a huge, huge impact on the overall R value. One thing that, as you do have to increase the size of your walls to accommodate the greater amount of insulation, something that we see often come up is difficulty around how to detail windows and where to place the window so it kind of performs as best it can. So the best strategy when it comes to fenestrations is to align the thermal break in the window with the insulation in the wall. That really reduces the risk of condensation, it reduces heat loss, and it really increases occupant comfort. And finally, in terms of this building enclosure approach to achieve and to comply with the NECB 2017 prescriptive requirements, we would just say to get creative. You can see here, as this gets towards a passive house wall, they've eliminated some of the structure in the wall that, typically you would just have old school is 2x4 and put the windows in, and your wall is much bigger than that now in order to achieve and comply with the NECB 2017. So here they've reduced the structure right around the window framing and then insulated around the window frame and around the structure that holds your window frame in place. So be thoughtful when you're detailing and get creative and take into account those thermal bridges. I'm going to pass it back to Mohammad now. Thanks.
Thanks, Maddie. So now I'm going to talk about prescriptive path, and I'm going to focus on mechanical systems. So one of the most important mechanical systems in our buildings right now is energy recovery ventilator. So here you can see in this table the requirements for energy recovery ventilator under NECB 2017. So the very first table shows the requirements for non-continuous ventilation, like if you have an office building or if you have a retail building. And as you can see, the requirement depends on three different parameters. One is climate zone. So when you go for colder climate, then the heat recovery is mandatory. And it also depends on percentage of outdoor air as design airflow condition. And it also depends on design supply fan airflow. So three different parameters to see whether heat recovery ventilator or energy recovery ventilator is required or not. Now, within the context of residential building, however, ERV or energy recovery ventilator is required for ventilation, except in climate zone 4, 5, and 6. So considering the map of the province, as you can see, most of the province is at climate zone 7 and higher. So for multi-unit residential building, ERV is required. And then the minimum sensible recovery efficiency for ERV is 50%. Now, what about other mechanical systems? So there are different tables in NECB 2017 which specify the minimum efficiency requirement for mechanical systems. And then here you can see, for example, for gas-fired boilers, the minimum efficiency required is 85%. Is it stringent? Oh, not that much. These are median efficiencies for industry. So you can easily beat these numbers by using new technology. Like right now, you're using condensing boilers. They are 95 to 97, 98% efficient. So you can easily meet these targets. All right, now what about performance path? So what is performance path? So we talked about prescriptive method. Maddie mentioned the fact that if you go above a threshold for your FDWR or fenestration and door-to-wall ratio, then you can't comply with prescriptive path anymore. And when you go with prescriptive, you can't trade off mechanical systems and building enclosure. So what is the most flexible approach? And that's performance path. Now, what is performance path? So performance path is done via energy modeling. And then with energy modeling, you're going to have two buildings. One is called proposed design, which is your proposed design. And then we have a reference building, which is a replica of proposed design. But that reference building must meet all the prescriptive requirements of NECB 2017. So now what you need to show is the fact that the overall energy consumption of the proposed design is less than the energy consumption of the reference building. Because at the end of the day, what matters to us is the overall energy consumption of a building. So what is an energy model? Energy model is essentially a collection of thousands inputs of building enclosure, mechanical system, electrical system, weather data, internal gains. So you sort of feed, energy modeler feeds all this to the energy model. And then the output of the energy model would be energy load, energy consumption, and carbon emission. All right, so my last slides. So I'm going to talk about the case study. So this is a case study. This is a residential building. It was a wood frame building. It's a 6-story building, and then it also had 2-level townhouses. The number of residential units was 73, and we designed this for Regina, climate zone 7A, and fenestration and door-to-wall ratio was 37%. So what I always do, I always place a render of energy model in the energy report and then graphically show how we can comply with the requirement. Now, for this specific building, we didn't want to just meet the base code. We wanted to be 15 to 20% better than code. And this is the strategy that we took to comply with that. So for exterior walls, as you can see, the strategy was to use 2 inches of semi-rigid and then R22 bath inside cavities. For windows, we use double glazed vinyl window with two coatings, which makes the U value pretty low, U 0.25. We use doors with insulated cores, and then we use R60 roofs. And then in terms of mechanical system, we use heat recovery ventilator, high efficiency heat recovery ventilator, low flow faucets, gas fire condensing water heater, fans with ECM, and then we also reduce the lighting power density in common areas by using LED lighting. Now here, my very last slide, what I'm showing is, so on the y-axis you see energy consumption, and on the x-axis you see energy end use. So as you can see, lighting, so the blue column is proposed design, and the other column is the reference building. So when we focus on lighting, we use LED lighting in common areas. So we show credit for lighting. Under NECB 2017, equipment and elevator are energy neutral, so we couldn't take any credit for those categories. With fans, we used ECM fans, very efficient fans, so we achieved significant energy reduction in fan energy consumption. With a space heating, as you can see, we still have a bit of a more higher energy consumption compared to the baseline building, because as Maddie mentioned, the R value of the baseline building or prescriptive requirement of NECB is pretty stringent, pretty high. So even though we push the building enclosure, we push the building enclosure details, we still have higher energy consumption compared to the reference building. But we are achieving saving under other categories. Like, for example, for domestic hot water, we use low flow fixtures and also condensing boilers, and we achieve significant reduction in that category. So this is essentially how we could show 20% reduction, energy consumption reduction compared to the NECB 2017 baseline building. Thank you very much. We are ready for taking any question.
Can you guys hear me?
Yep.
Oh, okay, great. So I was wondering, what is going to change in the new versions of the NECB standard? Like, what can we expect in terms of how everything's going to change? Or
yeah, great question. So what we see right now even under NECB 2017 is the fact that just like other versions, we still have performance path, meaning we have baseline building and proposed design. So we don't really see the effect of the shape of the building. So as you can see here, most buildings, they have same shape. So when we have articulation, for example, we don't see the effect of that increased surface area. However, under passive house and other contemporary energy standards, we only have the proposed design and we have target on the proposed design. So we don't have baseline building anymore. So this is what's going to happen to NECB in the newer version. We're going to have target for different steps. So it would be very similar. It would become very similar to the BC Energy step code.
okay, great answer. I don't know if you have other questions. If not, I would ask you, like, what are the main differences between the NECB and other contemporary energy standards, such as the BC Energy step code that I think you mentioned?
Yeah. So again, going back to the first question, I think the main difference between NECB and other contemporary energy standards as of right now is the fact that we still have a reference building and we are doing performance-based modeling. However, under BC Energy step code or Toronto green standard, we do target-based energy modeling. We have thermal energy demand intensity and total energy use intensity. And under City of Vancouver zero emission building plan, now we have GHG or greenhouse gas emission threshold as well. So we are moving from performance to target-based modeling. And this is going to be implemented in the newer versions of NECB as well.
Okay, great. Well, I would have maybe one other question. Do the proposed and baseline buildings have the same mechanical systems? Like, if you guys, I don't know if I could hear you on that.
Yeah. So, great question again. So, not really. So, there's a table in NECB, and then you select your baseline building. You select the baseline building based on the proposed design. But it's not exactly the same. It can be different. So it depends on how NECB defines the baseline building. So bottom line is they don't have the same mechanical system. You need to look it up under NECB under Part 8 of NECB 2017. Okay.
Okay, well, thank you so much for your presentation, Mohammad and Maddie. It was really interesting. And I also like to give a big thank you to our attendees. I'll also tell you that the session was recorded and will be available on canbim.com. So please tell your colleagues about CanBIM online events and join the CanBIM mailing list to hear about future events and initiatives. And up next on today's virtual session agenda, we have an executive session, Sustainable Business Models with Tim Caldwell, President at Chandos, at 11:30 a.m. Eastern Time. So we hope everyone enjoys the rest of the day and see you in the following sessions. Thank you, everyone.